Number 1, sketch a graph of the function h of x equals log base 4 of x on your own set of axes below. Highlight and describe key features of this function. So when we sketch the graph of a logarithm, we need to know important things, like the end behavior of it. A logarithm has an asymptote of x equals 0. The y-axis is the asymptote of logarithms in this form, functions of logarithms in this form, and they grow very, very slowly as x gets really large. There's a couple key points on the graph of a logarithm. The x-intercept, in this case, is 1, 0. When you're dealing with a standard log function with no shifts, just plain old log base b of x, it has an x-intercept of 1, 0, and it passes through the point of 4, 1. Why does this function pass through the point 4, 1? Because it's base 4. 4 to what power gives me 4? 4 to 1 gives me 4, so it passes through the point 4, comma 1. So in general, this is the point b, comma 1. And we said we have an asymptote of x equals 0, the y-axis, and it continues to increase on as x gets really large. The graph of log base b of x is shown below. Determine the value of b and explain your reasoning. So, looking at this graph here, I see that it passes through the point 7, 1. Therefore, b equals 7 because b equals 7 because log base 7 of 7 is 1. And if this passes through the point 7, 1, the base of the logarithm must be 7. Explain why this function does not have a y-intercept. So, for this to have a y-intercept, that means x equals 0. So what's log if y equals log base b of 0? This would say b to the 0, base to the exponent equals 0. And we know exponentials never equal 0, never output 0. So the domain of logs are from 0, not including it, so I can get really, really close to 0 to infinity. All positive reals. All positive real numbers. So that's why I don't have a y-intercept, because when I plug in a 0, it's undefined. It's not 0 is not in the domain of a logarithm. Explain why the x-intercept for all functions in this form is 1. So the x-intercept of a function is when y equals 0. So I'm going to set it equal to 0. Rewriting this as an exponent, I get b to the 0 equals x. And we know anything to the 0 power is 1. So therefore, x equals 1. So all the x-intercepts for log base b of x, they all pass through the point 1, comma 0. Once you start shifting it around, it changes, but at the parent log function, it's 1, comma 0. Find the x-intercept of this. I'm going to do it two different ways. So we know that it's the x-intercept is when it's equal to 0. The x-intercept is when y equals 0. So 2 to the 0 equals x minus 3. 2 to the 0 equals x minus 3. 1 equals x minus 3, so x equals 4. Or we can think about it in terms of a transformational perspective. So we know that this is an inside shift, so that means it goes left or right. So this shifts right 3 from the parent function of log base 2 of x. So that has an x-intercept of 1. So if I shift right 3, well, that 1 becomes x equals 4. And we see that we get the same answer whether we do an algebraic or a more graphical approach. Find the inverse of y equals the natural log of x. So we need to remember that the natural log of x is log base e of x. So to find the inverse, we switch x and y. I'm going to switch to log base e of x. Normally we don't do that, but this is the only helpful time to do that. And by x, I mean y. Switch x and y. And now I want to solve for y. I don't like the way this looks, so I'm going to rewrite it. E to what power gives me y? E to the x power gives me y. So the function f inverse of x is e to the x.